At a point in an elastic material under strain, there are normal stresses of 100 Newton per mm square, which is tensile, and 50 Newton per mm square compressive on two planes at right angle to each other. A shearing stress of 30 Newton per mm square acts on the same plane upward on the plane having 100 Newton per mm square stress. Find Pn and Pt on a plane making an angle of 30 degree with plane of first stress. First stress P1 is this, which is tensile and plus 100 Newton per mm square. The second stress P2 is compressive, so it is minus 50 Newton per mm square. Shear stress is upward on the plane of 100 Newton per mm square stress, so it is positive, and a plane is inclined by 30 degree, so its normal will make 30 degree from the axis X or the direction of P1. We have to find Pn and Pt on this plane. So from the transformation equations, we have relation for Pn and Pt. Pn is equal to 1 by 2 P1 plus P2 plus 1 by 2 P1 minus P2 cos of 2 theta plus Q sine of 2 theta, and Pt, the tangential stress, is given by minus 1 by 2 P1 minus P2 sine 2 theta plus Q cos 2 theta. So let us calculate the values of Pn and Pt. Pn will be equal to 1 by 2 plus P1 is equal to 100 plus P2 is compressive, so it is minus 50. So 100 plus minus 50 plus 1 by 2, 100, again P1 minus P2, 100 minus 50. Cos 2 theta, theta is 30, so we will take cos 60 plus 30 sine 60, 30 is the shear stress Q. So which comes 100 minus 50 by 2, 25 plus 100 plus 50 by 2, 75 into cos 60 plus 30 sine 60. Putting values for cos 60 and sine 30, we get value of Pn equals to 88.48 Newton per mm square. Now calculating the values of Pt. Pt is equal to minus 1 by 2 P1 minus P2, so 100 minus 50 sine of 2 theta, that is sine 60, plus Q, that is 30 cos 60. 100 minus 50, 150 by 2 gives 75 sine 60 plus 30 into cos 60 is 1 by 2. So which gives a value of Pt equals to minus 49.95 Newton per mm square, and the resultant PR of Pt and Pn will be equal to root Pn square plus Pt square is equal to root 88.48 square plus minus 49.95 square. So which gives a value of PR equals to 101.6 Newton per mm square, and the angle psi, which the resultant PR makes with the normal component Pn, is given by such that psi equal to tan inverse Pt by Pn. So that is equal to tan inverse minus 49 0.95 upon 88.48. This gives a value of psi equal to minus 29.24 degrees. So if Pn is in this direction, which is 88.48 Newton per mm square, Pt will be in a perpendicular direction like this, and which is 49.95 Newton per mm square. So PR will be in a clockwise direction angle of psi, that is 29.24, like this. So let us find graphical solution for the same problem, which is also called Mohr circles method. So let us recall the stress condition of the element. P1, that is 100 Newton per mm square. P2 is minus 50 Newton per mm square since it is compressive. And shear stress of 30 Newton per mm square in the direction shown. Plane is inclined at 30 degree. We have to find Pn and Pt acting on the plane. The normal Pn is at 30 degree from the x-axis. To start with, we will draw from the origin O a line which is equal to P1, that is 100 mm line, like this. Origin is O, A is the end point, and length is 100. Since the other stress is negative, we will draw it in negative direction of x and equal to 50 mm. Let's say this point is B. So OB represent the stress P2, which is compressive. From A, we will draw the shear stress condition. Since shear stress is trying to rotate it in anti-clockwise direction, it is positive, so it will be drawn on Mohr's diagram downward the x-axis like this. This point is Z, and from B we will draw the shear stress 30 mm upward, since the plane which is carrying the compressive stress is rotated in clockwise direction by the shear force. If we join the point F and G, it will pass through the midpoint of line AB. So let us join these 3 points F, C, Z. Let center be C. So from the center, we will draw a circle with radius either CZ or CF, since both are of same length. So let us draw a circle like this. Which will pass through point F and G, both, and radius, and the center is C. Now we will rotate the line CZ by 2 theta, that is by 60 degree. Let's mark the point and extend this line till the circumference of the circle drawn. So from C we will draw a line, radial line, till the circumference. The angle is 2 theta. Since theta is given 30, we will take 60 degrees. Let the point be D. From D, we will drop a perpendicular on the x-axis, which represent PT on the Mohr's diagram. So let this point be E. So DE represents tangential stress PT, and OE represent the normal stress PN. And the line OD represent the resultant of PN and PT, which is PR. So now let us measure OE. So we'll get value of PN by the graphical method by measuring OE, which comes 88.5. And now let us measure the line DE, which will be the graphical value of PT, and this comes PT is equal to 50. And the line OD, which is measure of PR on the Mohr circle, and the value of PR comes equal to 101. And the angle psi is represented by angle DOE on the Mohr circle. So let us measure the angle DOE, which is the angle which the resultant makes with the PN, and value of psi comes 30 degrees. So let us write down the values obtained by the Mohr's diagram. Pn is equal to 88.5 Newton per mm square, Pt is equal to 50 Newton per mm square, Pr is equal to 101 Newton per mm square, and psi is equal to 30 degrees. At a point in loaded structure, a compressive stress of 100 Newton per mm square and tensile stress of 40 Newton per mm square on two planes at 90 degree to each other are acting, along with a shear stress of 50 Newton per mm square downward on plane having 100 Newton per mm square stress. As in figure, plane is obtained by rotating the element in clockwise direction by 20 degree. Find stress on the rotated element. So let us solve this problem graphically by drawing Mohr's circle diagram. So we start with drawing P1 and P2 on x-axis. Since P1 is negative from the origin, it will be drawn in minus x direction. So from the origin O in minus x direction, let us draw a 100 mm line representing the 100 Newton per mm square stress. Let origin be O and this point be A. Length OA is 100. And since P2 is positive, it will be drawn in positive side of the x-axis. So draw a line of 40 mm OB on the positive side of O. So let this point be B. So OB is 40 mm. The shear stress is trying to rotate the plane carrying 100 Newton per mm square stress in clockwise direction. So stress is negative, and a negative stress is drawn upward the x-axis. So from A, let us draw a line of 50 mm representing the shear stress. Let this point be G, and similarly the plane which is carrying stress of 40 Newton per mm square, the shear stress is trying to rotate it in anti-clockwise direction. So the shear stress will be drawn below the x-axis, since on Mohr circle it is positive. So let us draw a line BH of 50 mm representing positive stress Q. If we join the point GH, they will pass through the center of the AB. So let us join these 3 points G, C and H. Now we will draw a circle from the center C of radius either CH or CG, since both are equal. So let us draw a circle like this, passing through G and H and C at center, like this. Now the rotated element is obtained by rotating 20 degrees in clockwise direction. So clockwise angle is taken negative. The line CG represent the stress P1. Stress condition of P1 is represented by point A, and stress condition of vertical plane is represented by point P, which is 40 Newton per mm square. So let us rotate the line CZ in clockwise direction by 20 degrees, and let us extend the line till the circumference of the circle, which meets at point D. Now if we drop a perpendicular from D on the x-axis, and say this point is E, then the length OE represent the PN, the normal stress, and DE represent the PT, that is the tangential stress on a plane which is rotated by 20 degrees clockwise. And the line OD represent the resultant of PT and PN, which is PR. And the angle psi which the PR makes with PN is angle DOE. So let us say it is psi. Now let us measure OE, which will be the graphical value of PN, which comes 55. And let us measure DE, which is the graphical measure of PT, or the tangential stress, and which comes 84. And let us measure the resultant PR by measuring OD. So the measure of resultant PR is 100 Newton per mm square. So these are the values we have obtained graphically. Now let us measure the angle psi, that is angle DOE. It is being measured in anti-clockwise direction, and it comes about 57 degrees. So let us write down the values obtained graphically. Pn is equal to OE is equal to 55 Newton per mm square, and is in negative direction, so it is minus. PT is equal to DE is equal to 84 Newton per mm square. Since it is above the x-axis, it is negative on Mohr's diagram, and PR is equal to DO is equal to 100 Newton per mm square, and the angle psi is 57 degrees, and it is positive since it is measured anti-clockwise. So there are certain sign conventions. We take positive stress in positive x direction, negative stress in negative x direction, positive shear stress below the x-axis, negative shear stress above the x-axis, and an angle clockwise is negative and an angle anti-clockwise is taken positive. So let us find now numerical solution, that is by the formula obtained by transformation equations. So P1 is 100, P2 is 40, Q is 50, and theta is 20 degrees. So 2 theta is 40 degrees. These are the stress conditions, shear stress downward, P1 compressive, P2 tensile, and this rotated element by 20 degree. So we know that from the transformation equations, Pn is equal to 1 by 2 P1 plus P2 plus 1 by 2 P1 minus P2 cos 2 theta plus Q sin 2 theta, which is equal to 1 by 2, P1 is minus 100 plus 40 since P2 is positive, plus 1 by 2 minus 100 minus 40 cos of minus 40 since the rotation is in clockwise direction, plus minus 50 since shear stress is negative, sine of minus 40. By simplifying, we'll get values 60 minus 60 by 2 minus 30 minus 53.6 plus 32.14, which is equal to minus 55.79, which is value of Pn. And Pt from transformation equations is equal to minus 1 by 2 P1 minus P2 sine of 2 theta plus Q cos 2 theta. So putting values, we have Pt equal to minus 1 by 2 minus 100 minus 40 sine of minus 40 plus minus 50 cos of minus 40. Simplifying, we get 140 by 2 minus 70 sine 40 minus 50 cos 40, minus minus becomes plus 50 cos 40 within brackets. So simplifying and calculating values for sine 40 and cos 40, we get the value of Pt equal to 83.29, and the psi, the angle which the PR makes with Pn is tan inverse Pt by Pn, will be equal to tan inverse minus 83.29 upon minus 55 by 0.79, which gives value of psi equal to 56.2 degrees. So if we match the values obtained graphically and values obtained analytically, analytical values are Pn is equal to minus 55.79, Pt is equal to 83.29, both are negative, and psi is equal to 56.2. If we see on the Mohr's diagram, the Pt is above the x-axis, so as per sign convention it will be negative, so it is minus 84 Newton per mm square. OE is also in negative direction of x-axis, so Pn will also be negative. The angle psi is being measured anti-clockwise, so it will be positive, which is 57. So we see that graphical and analytical values are exactly